class. Welcome to lesson 2.3. Let's take a look at some of our warm-ups. And in this case, we're going to take up page 95, numbers 6E, 9, and 10D. Again, looking at 6E, it's an expanding of a trinomial. So there's no quick short form to do this like expanding a binomial, so you have to simply rewrite each factor out twice. And then remember that every term in the first bracket has to be multiplied by every term in the last bracket. So in fact, when you're done expanding this, there should be 9 factors, 3 in this case for each color. So first of all, I'll start and multiply the 4x by every term inside the second bracket and get my black terms. And then I'll take the y and multiply it by every term in the second bracket and get my blue terms here. And then I'll take my -3 and multiply it by every term in the second bracket and get my green terms. Then after you're done that, ladies and gentlemen, collect like terms and compare this expression, which is the one I have here. I'll just highlight it here. This expression with the expression given. And what you'll notice is that there are some differences, although maybe at first glance you may not notice. But look at the negative sign in front of 8xy, and here it's a positive sign, whereas you have a positive 24x and here a negative 24x. So even the signs, if they're different, that tells us therefore these two are not equivalent. Taking a look at 9, you were asked, given some surface area, and I think you had to replace the radius with 2x plus 1 and the height with 2x minus 1. When you substitute that in, ladies and gentlemen, you have to then do some simplification. Again, looking at the surface area here, I use the shortcut. When you square a binomial, you do the square the first, double the product, and square the last. Okay, and again in the second part of this, I used FOIL, first, outside, inside, last. And then I still had to use my distributive law to multiply 2 pi by that expression and 2 by the second expression. And then after you're done all that, then you can finally collect like terms. Looking at your second example, ladies and gentlemen, once you substituted in R, again you had a squaring the binomial. So square the first, double the product, square the last, and then, ladies and gentlemen, you still have a binomial times a trinomial. So every term in the binomial gets multiplied by every term in the trinomial. And then again, after you collect like terms, you multiply everything by pi and just change the order if it's not in proper order. Again, highest power exponent first, and then the lower powered exponents. Okay? So that was 9. Scrolling down here, number 10 is x minus 3 cubed equal to 3 minus x cubed. And again, this is something where you have to expand it out, multiply 2 binomials first, and then multiply the binomial times the remaining trinomial. And you do that in both cases, ladies and gentlemen. And you will notice that they do not have the same answer. So therefore, x minus 3 cubed does not equal 3 minus x cubed. Therefore, they are not equivalent. All right, ladies and gentlemen, today we're taking a look at factoring polynomials. Just remember, if you take a look at an example like this one I have up here, folks, depending on which direction you go, you perform different operations. So as you go from left to right, you're doing what's called expanding. And if you go from right to left, you're doing the opposite, which is called factoring. And you can perform the opposite operation in order to check. So you check, so if you expand it initially, then you're going to check by factoring. If you factor first, you're going to check by expanding. Now there are 5 different types of factoring. Again, this is a review of grade 10. If you're having trouble with this, please check the appendix book or appendix section in your textbook. They have a good review on factoring review. Okay? So check that out if you need some extra help. This is going to be the time-consuming thing that I hope from grade 10 that you can improve upon. So let's take a look at the first type of factoring, common factoring. We always try to common factor first, ladies and gentlemen. And what you realize is that you need what's called the GCF, the greatest common factor, i.e. what number or term goes into all 3 terms. In this case, we have a 3 that goes into each of these 3, but we also have a variable that goes in. So our greatest common factor is 3m. It gets put out front, and then the remainders, or what's left over, after you divide each term by 3m, go in the brackets. So this is your common factor, and these are your leftovers, what we call them in the brackets. Example 2 is factor by grouping. This may be common, or you might have noticed this from doing decomposition. Okay, so this is step 2 in decomposition. So we look at the first 2 terms that are in blue, what's common in them, k squared, so you factor out k squared, what's left, k plus 3. Look at the last 2 terms in red, what's common in those 2, -2. You factor out a -2, and what's left over is k plus 3. Whenever you factor by grouping, ladies and gentlemen, you should notice that you end up with a common, oops, sorry, let me undo that. That was pretty bad. We end up with a common binomial. So what are we going to do then? We're going to factor k plus 3 out of both terms. So that becomes your first factor. And then what's left over, k squared minus 2, becomes your second factor. And in B, take a look, folks. They actually have simplified it, and you found that, hey, there's a common binomial here already. So it's a little less work. So just recognize, hey, those binomials are your greatest factor. So then what do you have as your leftovers? 3y minus 4. Okay, now we're getting into more harder stuff. Again, we're going to take a look at simple factoring. Simple trinomial factoring is when a equals 1 in standard form of a quadratic. So look at this first example here, a equals 1. In my classes, in the previous classes, we've talked about finding the product and the sum. The product is always a times c. So in this case, it's 1 times -40, which is -40, and sum is your b value, which is -3. So what numbers multiply to -40 and sum or add to -3? In this case, we have 5 times -8, so those become your factors that go in here. So x plus 5 and x minus 8. In grade 11, ladies and gentlemen, as long as I see product and sum and the factor number that works here, I'm okay with that. I don't actually need all the list, but if you need that in order to pick your factor, please include it. But I won't be giving marks for it. I'm just going to expect you to know how to do that from grade 10. Okay, taking a look at example B, a does not equal 1. However, we always look to common factor first. This is going to make life easier if we can remember the common factor. So here's my hint. Look for A. A is 3. And does every term go in evenly by 3? Yes. So we're going to common factor out of 3. What's left over is now going to become the simple trinomial. So again, when you take a look at factoring a trinomial, product is a times c, so 1 times 2 is 2, and the sum is 3. What 2 numbers multiply to 2 and add to 3? 1 times 2. So those become your factors. And in this case, we have 3 terms. The 3, which is a common factor, and 2 binomials. So together, 3 terms. All right. Now the next easiest type of factoring, it's one of my favorites, is called difference of squares. And how do you recognize it? Difference means you have to have a subtract sign, and of squares means it's perfect squares. And if you're just talking difference of squares, then you need to have a binomial. Okay? It can't be the addition of squares, it can't be the division of squares, it has to be the difference of squares. So notice in this first example, we have subtract sign, that means difference, and of 2 terms that you can easily take the square root of. So what we basically do, ladies and gentlemen, is set up 2 brackets. I put a positive sign in one and a negative in the other. I take the square root of the first term. So square root of x squared becomes x. You put them in the first part of your brackets, and then square root of the last term is 4. So you put it in the last part of your term. The reason why you need to have a positive in one and a negative in another is if I was to expand this out, use FOIL, first, outside, inside, and last, the positive and the negative would cancel out those middle terms so that you would just end up with a binomial as you check backwards. All right? Okay. Taking a look, ladies and gentlemen, at example B. Again, do we have a difference of perfect squares? Well, not yet, but we always check to common factor first. What value goes into 75 and 3? It's 3. So common factor out of 3 first, and then what's left over, ladies and gentlemen, is 25p squared minus 1. And again, that's where we're going to break that down into difference of squares. Keep the 3 out front, set up two brackets. One's got a positive, one's got a negative, and take the square root of the first and the last term. Now, the hardest factoring type, dun dun dun, is decomposition. And I know people get frustrated with this one because it takes a lot of time and it's a lot of work. How do we recognize decomposition? It's a trinomial where a does not equal 1 and it can't be factored out. The key here, guys, is we're going to split the middle term up into two things. So we're going to have 4 terms, and then we're going to common factor by grouping. Let's look at A here. First of all, A is not 1, it's 12, but we look to see if we can reduce that. Is there any term that goes into all 3 of these? Yes, it's a 2. So common factor out of 2. What's left over is 6x squared minus x minus 1. Then you do your product and your sum. Again, product is A times C. So 6 times negative 1, which is negative 6. And your sum is negative 1. What factors multiply to negative 6 and sum to negative 1? 2 times negative 3. So what's different here, folks, is that we split the middle term. Notice in the blue, it doesn't matter which order you do first. Okay? You're just going to split that middle term, and then you factor by grouping. So take a look at the first 2 terms inside the brackets. What's common at 2x? What's left over when you factor that through is 3x plus 1. Looking at our second value, what's common? Hey, they both have negative signs. We're going to take out a negative 1 as a common factor. So we have 3x plus 1. Again, in this situation, you should notice that your brackets should be the same. So it's your common binomial. And then your leftovers are 2x minus 1. Try another example here. Try B. Check out B. Is there any number that we can common factor into all 3 of these? No. So we just work on decomposition. Again, use a side margin. Product equals 12, which is 2 times 6. And our sum equals 7. What 2 numbers have a product of 12 and sum to 7? 3 and 4. So again, you split the middle term into 2 terms. Again, when you split it up, folks, it's still, if you add those 2 terms together, 3x plus 4x, still eats 7x. So we keep it balanced. We just change it from 3 terms to 4 terms. Okay? And then, ladies and gentlemen, look at the first 2 terms. What can we factor out of there? An x. So we have 2x plus 3 left over. And your last 2 terms, what's common there is a 2. What do we have left over? 2x plus 3. Now take a look, ladies and gentlemen. We have a common binomial here. So that becomes our first factor. And our second factor is our leftovers, which are the products that were multiplied by. So x plus 2. Again, ladies and gentlemen, it is very important that if you struggled with any of these factoring types last year, please come and see me and spend some extra time, because we are going to build on this and it's going to get more difficult when we look at doing restrictions and multiplying rational expressions. So your homework for today is page 102, numbers 1, 3, 4a, b, c, d, and 5 and 6. Good luck with that. And again, if you need some help with factoring, please check the appendix in your textbook. Have a great day.